Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Quick note before we begin, the Finding Genius Foundation, as part of the Finding Genius Podcast, has recently completed a book about understanding viruses. So the creation of this book was to interview 100 virologists, ask them a lot of deep, difficult questions, take the most difficult questions, and then re-interview the top 25 or so and ask them the hardest questions I could think of. And we compiled that all into a book. So you'll see question and 4 or 5 experts' answers. Question, 4 or 5 experts' answers. There's about 30 questions in the book. I think it's a great read for the layperson and for the researcher. It talks about a lot of speculation in the world of viruses, such as are they alive or not, and why is it important? Why do viruses go latent or hidden or ineffective or sit in a person or an animal or another creature for weeks, months, years, and then suddenly become virulent and affect that person? So there's a lot of really provocative questions in the book. It's now on Amazon. So if you go to Amazon and type in Finding Genius, you'll see the book on viruses. It's also on Kindle. The Audible version is in production and should be ready in approximately a month. But if you want to go and order it now, you can do so again by going to Amazon or Kindle, or go to findinggeniusfoundation.org and go to publications. There's an opportunity as well to get the transcripts of all the interviews and to hear the original interviews themselves. If we put them all together, the book would be about 1,000 pages, but we condensed them down to make it juicy and concise and tight and very interesting. So I hope you'll check out the book. We're now working on one about cancer, but this is going to be our goal is 3 times a year to come out with these masterclass books that I think will inspire new scientific research, and I hope you'll check it out. Thank you. Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. I have Dr. Ronald B. Brown, Ph.D. We're going to talk about some topics related to COVID. So, Ronald, thank you for coming.
Thanks, Richard.
Yeah, tell me a little bit about your background. And, what was your interactions like with COVID when it first hit and today? But your background first, if you don't mind.
Well, I'm an American, but I live in Canada. I came to Canada in 1976 after the Vietnam War. And I'm a professional musician in one of the local symphony orchestras here in Ontario, Southern Ontario. And although I have a degree in music, I've always had an interest in science. So when I began my music career, I decided to continue my science studies as a part-time student. And I eventually worked my way up to becoming a Ph.D. I hold a Ph.D. in organizational behavior, industrial organizational behavior. I've always been interested in health. I have a Bachelor of Science degree in dietetics. And I'm currently a doctoral student in public health epidemiology at the University of Waterloo. That's my affiliation that I publish all my articles under at the moment. COVID-19 was the great disruptor of my of my career. It was disrupted everything. It disrupted my social life. It disrupted my work. It disrupted my academic work. It had an impact on my finances. So I pretty much dropped all of my other research directions at that time and decided to look at this particular issue. And it's not like I didn't have the extra time to do it. So I spent the whole year researching everything I could find about COVID-19, specifically the causes of the disease. Also, I was very much interested in researching the vaccines. During the course of the pandemic, last March, a year ago from March, it was first announced that we have to lock down until we until we develop vaccines. And that's when it occurred to me that, this would be a good time to focus the public's attention on how vaccines are developed in real time and how the randomized trials are conducted in real time and how the outcome is reported. So a year later, I have now 2 articles on COVID-19. both which are very successful. They're both the most read articles in the journals that they're published in. My most recent one was called Outcome Reporting Bias in COVID-19 Messenger RNA Vaccine Clinical Trial. So we can talk about that. The other article that I had came out last August, and that one was called Public Health Lessons Learned from Biases in Coronavirus Mortality Overestimation. Now, you got to understand, these are scholarly, peer-reviewed articles, so the titles aren't exactly catchy, but...
Well, let's get into the premises then. So the first article, what was the main premise of the abstract?
Well, the Public Health Lessons Learned, I got the idea to write this when I was listening to information on the media claiming that this novel infection was 10 times more deadly than the flu, which I thought was kind of unusual to be able to make a statement like that at the beginning of a pandemic over a disease we'd never heard of before. So it kind of sent up red flags to me when I listened to this. And then I also heard that we should, if we were overreacting to the virus, we were probably doing the right thing. This was another red flag that made me decide I'm going to focus all on this. So I started doing my research, putting together all of this information. And since my area is epidemiology, it was a good opportunity to investigate the difference between infection fatality rates and case fatality rates in COVID-19. Because what's
the difference between those two for listeners?
Yeah, I'm going to explain. Well, what I was hearing, I soon discovered this statistic that COVID-19 was 10 times more deadly than the flu was actually based upon a conflation of the infection fatality rate and the case fatality rate. Now, all cases are infection for any disease, including COVID-19, but not all infections are cases. So, for example, you can have an asymptomatic infection of COVID-19, or you can have a minimal infection. So you're not really a case. And the fatality rate for cases is therefore much higher and much more narrowly defined than it is for infection fatality rates.
I had thought the definition of a case had been recently changed. What was it and what is it? And has it changed?
Case definitions are always changing.
Just case, not case fatality, but just what is a case? What does that traditionally mean versus now?
Sorry, that's exactly what a case definition is supposed to do. It tells you what criteria are we looking at to determine that this is a case or not. And usually it involves things like laboratory testing, the PCR testing is one example. And then we have clinical signs and symptoms is another criteria that's used. And also other epidemiological criteria includes, for example, contact tracing, things of that nature. You know, who have you been in contact with lately? And there are all kinds of complicated definitions out there. I don't really want to get into discussing all the details of every one of them, but they're constantly evolving and they involve a combination of these types of criteria. At the beginning of an outbreak, it's not unusual to have a very broad case definition so that you include all kinds of things. You cast a wide net to include all the evidence that you need to determine exactly what's going on in the outbreak. But eventually you want to avoid bias by using that wide, a broad or broader case when you're actually trying to interpret how lethal, how many fatalities there are. You can't just include all the other factors that you might do at the beginning for investigation purposes. You have to be careful that you don't use all of that information to bias your mortality estimations. And this is what was happening back in the early part of the outbreak a year ago. So I was hearing that, you know, the case fatality rate of influenza was 0.1%. I was right. The case fatality rate of the coronavirus is 1%. But the case fatality rate of influenza is not 1%. It's 0.1%. All right. There was a mix-up between comparing case fatality rates of the coronavirus with infection fatality rates of influenza. And so it came out that the coronavirus case fatality rate was 10 times higher than the influenza infection fatality rate. You're comparing 1% with 0.1%. And that's mathematically correct, except that you're comparing apples and oranges. You shouldn't be comparing case fatality rates with infection fatality rates. And based upon that error, the public was told this is 10 times more dangerous, the coronavirus, than influenza. And that helped to launch all of the lockdowns that we've been experiencing ever since.
So again, now in the right context, an infection is a less of a standard than an actual case. at least as it pertains to COVID, or no? Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now, back to the show.
Well, an infection is broader. Now, this is interesting because a case is specific. You're sick. You're sick enough usually to be hospitalized, right? And so your risk of death is increased compared to somebody who's asymptomatic, right?
But that's not how it's been reported at all. A positive PCR test is considered a case as regards to COVID.
Exactly.
So they always talk about cases surging. So is that inaccurate? Is the definition of a case completely wrong in this situation?
Simple answer, yes. And that's what my third article, I'm writing that manuscript on it. I actually have written it and I'm revising it right now for peer review. The World Health Organization, in their case definition of the coronavirus, conflated the distinction between infection fatality rates and case fatality rates. So anybody who has a laboratory confirmed infection, regardless of whether or not you have any clinical symptoms, is now a case. In other words, an infection is good enough to mean you have a disease. And so how does that affect fatality rates? It means that if you die of anything while you've had this infection, in other words, while you've had this other disease called coronavirus disease or COVID-19, then that also gets listed in the fatality statistics. This is exactly the type of problem I was just talking about before, where you have such a broad definition that it biases the actual number of fatalities.
The people that are supposed to be in the know, what does that tell you if they've conflated these two things and the media has reported this in the wrong way for, well over a year now? What does that tell you? Should they have known better, or is it an honest mistake?
You know what? I think I'm going to side on the honest mistake. I'm not a conspiracy theorist. I don't think any of this was really intentional. I think it was just people making mistakes. You know, the director of the National Institutes of Allergies and Infectious Diseases apparently didn't have much quality assurance procedures to correct any mistakes that he might have been disseminating to the public. World Health Organization made all kinds of mistakes. And I'm writing this up right now. I don't want to get too much into the details until it's peer reviewed, but let me tell you that the World Health Organization recommended that all other nations follow China's lead in handling the coronavirus at the beginning of the pandemic. China had declared an end, more or less, to cases and infections and deaths. To this day, the total amount of deaths claimed by China is just over about 4,600, compared to what, 500,000, over 500,000 in the United States alone. So what is China doing that's so wonderful that we're not doing? Well, my third article, is looking at the case definition that China uses. It's much different than the case definition that the World Health Organization and all the other countries outside of China. China doesn't even call the coronavirus. They call it novel coronavirus pneumonia. You know, in Wuhan, the first 4 cases were pneumonia cases, but they couldn't find a pathogen that was traditionally linked to pneumonia. So when they did some genomic sequencing, they came up with this new pathogen, coronavirus 2, SARS-CoV-2, and said, okay, so this is a novel coronavirus that's associated with pneumonia, and that's it. And they've always defined it as pneumonia. If it's not pneumonia in China, it's not coronavirus. It's not COVID-19. That drastically cuts down on the amount of cases you're going to define compared to us and the World Health Organization, for example, where anybody who has an infection is a case. You see the difference right there? So
So China's data is all based on the person having pneumonia-like symptoms. What is the determinant that says you have pneumonia or pneumonia-like illness?
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
I was just going to say, they have to identify a specific pathogen, a viral pneumonia pathogen, to declare it pneumonia. And if they can't find that and they find SARS-CoV-2, then it gets defined as a case, only in that example. So that narrows it even more. So not only do you have to have only pneumonia cases, you have to have pneumonia cases where there's no other pathogen involved, viral pathogen, other than the novel coronavirus. So you can imagine when you have that narrow a case definition, how many cases are you going to have? What do they have? 1.3 billion people in China. And after a year, they've had 4,000 deaths or 90,000 cases compared to what we have. And it's all because of the case definition.
Okay. So why would China continue to have these lockdowns, and why would they now have a vaccine passport if they now have data that shows that the death rate is incredibly low?
All right. So I explained why their death rate is low because of their case definitions. World Health Organization, unfortunately, did not figure that out. Now, I can't blame them. Again, this is just we could say, yeah, they should have known better. They should have realized that the reason why China seems to be doing so well is because they're simply defining their cases differently. But they didn't do that. You know what they did? They did the exact opposite. They said, hey, everybody else, China's doing great. You should copy what they're doing. But wait a minute. They are a totalitarian dictatorship. They're locking down their whole country. We've never done anything like that before. But you know what? We were so desperate, we went right along and did exactly what the World Health Organization told us to do. We copied these draconian lockdown measures with all the collateral damage and with our democratic freedoms being compromised based upon a method claimed to be effective by an authoritarian dictatorship. So we've got a huge problem on our hands. More importantly, we have to understand how this happened so it doesn't happen again. Now, to make things even more complicated, we also have new genomic sequencing that's been playing a major part in this too, because you can't have a novel coronavirus unless you come up with a novel genome sequence. And right now, the genomic sequencing technology sector is growing by leaps and bounds. If you want to make a lot of money overnight, get into genomic sequencing, because that's what's happening right now. Here's the problem. There's a huge gap in all these new sequences of genomes coming out for all these pathogens, and the ability to identify from an epidemiology point of view exactly how dangerous they are. You might have heard about the variants of concern. Concern tells you everything you need to know right there. We don't know exactly how dangerous they are. We're just concerned that they might be dangerous. So there's this huge gap that's not being filled in by the epidemiologists. The epidemiologists are kind of being left out. The information is going direct from the genome sequencing technicians to the public health people, who are then panicking. What's missing is the proper interpretation of the genomic sequencing data by the epidemiologists. But that takes time. That takes, it takes serial surveys. It takes all kinds of case control studies. And we don't even have time to figure all that out. What the public health people, in my opinion, should have said was, well, this is a concern, but we shouldn't do anything now. Just keep an eye on it. That's the way we've always done these things. Look at Ebola. I mean, there was a big concern about that, but we didn't lock everybody down. The difference is that in this case, World Health Organization made a mistake by thinking that China successfully mitigated all of their infections with their lockdown measures, and therefore advised everybody to copy their lockdown measures. So you see what a web of a mess this is? We have to get this all straightened out. And then that, of course, then brings us to the vaccine.
So, I mean, when I looked at GISAID data and some of the, the surveillance data, there's tens of thousands of variants, and this has been known for a long time. Mm-hmm. So why all of a sudden are they saying, oh, there's a new variant and we have to shut down again? If it's
case definitions. What's happening?
There's at least 40,000 variants from someone I spoke to at the CDC. So this really doesn't seem to be honest. This seems to be, you can call it what you want, but I just don't understand how people could be wrong that are supposed to know. And after a year, there's no admissions of wrongness. There's no nothing. It's just continuation of the same.
It's much more than 40,000. Last count was over 300,000. So I have the data for that. I'll have to look that up. But anyway,
Right.
Here's the point. It boils down to the case definition again. Remember, one of the criteria for the case definition is laboratory testing, right? Well, if you broaden the amount of variants you're testing for, now you got more cases. And you know what? I'm in Canada right now. We're locked down again. It just started a few days ago. Why? Because now half the cases that are now being reported are variants. And why is that? Because now we're officially testing for them. I'm not sure the United States has reached that point yet, but I know in Ontario, the Ministry of Ontario declared that all laboratories will now test for these variants. And as soon as they did that, within 2 days, the cases started to jump up. So here we go again.
What about the cycle threshold in PCR tests? I mean, supposedly it's supposed to be 30 max or even less, and it was run to 45 from what I've seen. So that would also massively increase what's considered a case.
Yeah, the higher the cycles, the less reliable, right?
Well, I calculated 30 doublings of one viral particle is 577 million. 45 doublings is 17 trillion, which is a 10,000-fold difference. But I have yet to hear what is the pass-fail for the number of material found.
But you know what? You know what? I understand what you're saying, and it's an issue, the cycling and stuff of the PCR testing, and also the false positives. And I might say also the false negatives too. People don't mention that. But that's a constant in a way. It's still a problem, don't get me wrong, but it's more or less, we've always had those sorts of problems. These other problems I'm talking about are kind of unique to this situation. It's because of the changes in the case definitions, the misinformation coming from the World Health Organization, the misinterpretation of the genome sequencing. You start adding all of this stuff together, and now you have a terrible situation that we're living under. So I hear what you're saying about the test.
Well, let's move on to the vaccines, both mRNA and I guess traditional adenovirus vector.
Right.
I guess.
Now, my article was basically just on the messenger RNA vaccines, but with the statistical analysis problem that I came upon is it applies to all kinds of vaccines. Not only does it apply to vaccines, it applies to any treatment that's tested with a randomized controlled trial. It's a question of how you report the outcomes. Now, randomized controlled trials are the gold standard. They're the highest level of evidence you can have. So when they say the vaccine efficacy of, for example, the Pfizer and the Moderna vaccine is 95%, around there, 94, 95%. They are correct. It is. That's not the question. The question is that the complete information? We're not getting the entire information. It turns out that vaccine efficacy is based upon a statistic known as the relative risk reduction. What's missing is another statistic known as the VDPI, the vaccine disease preventable incidence, otherwise known as the absolute risk reduction. Now, have I completely confused you with the jargon so far? Because that's basically what the vaccine depends upon, that you're not going to care about the absolute risk reduction. All we're going to give to the public is the relative risk reduction.
Well, that happens with a lot of drugs, like Lipitor and things like that. Let's say the absolute risk, I'm not saying for that, but for some condition is 1%. And then through clinical trial, they say, it's reduced by 50%. And they only showcase that. But you may go from 1% risk to 0.5% risk, or 0.1% to, a fifth of or 20th of a percent. So they don't show both. They don't disclose both. I mean, I guess same thing here, right?
That's good. So you're letting me know that you're somewhat familiar with this. Okay, that's good. So let me get into the details. All right. So the FDA, Food and Drug Administration, put out a list of recommendations saying that for the dissemination of randomized controlled trial results to the public, you must report both of those outcomes, the absolute risk reduction as well as the relative risk reduction. But that's hardly being done at all. In fact, the FDA advisory committee that authorized the vaccines for emergency use didn't do that. The New England Journal of Medicine that published the data of those two vaccines, Moderna and Pfizer, didn't do that, didn't include that. So we have a problem here of informed consent. the public is not being informed about all of the information it needs to make an informed decision about how effective this vaccine is. They're only getting half the information. So basically, let me go walk through this. I won't take up too much time on this, but just to kind of give you an idea of how these numbers are calculated. Randomized control trial, you have two groups, vaccine group, placebo group. Let's say you have 100 people in each group, just for an example, okay? And then what you're going to look for during the course of the trial is what we call an event. In other words, in this case, an event would be a symptomatic infection, all right? Just one clinical symptom. And then you compare how many events you've had by the end of the trial in both groups. So let's say you had 2 events in the placebo group, all right? In this case, 2 SARS-CoV-2 infections, and 1 event in the vaccine group, all right? And remember, you have 100 people in each group. So you have a 1% event rate in the vaccine group, 1 out of 100, and you have a 2% event rate in the control group, 2 out of 100. What you do is you subtract the event rate in the vaccine group from the event rate in the control group. So 1% from 2% is 1%. That is your absolute risk reduction, okay? However, how do you get the relative risk reduction? Well, you take that 1% and you divide it by 2%. In other words, you take the VDPI, the vaccine disease preventable incident, that 1%, otherwise known as the absolute risk reduction. How is that relative to people in the control group who didn't get the vaccine, which is 2%? So you're dividing 1% by 2%. Now, this is interesting. A mathematical property of percentages is that when you divide them, you get a higher percentage. Usually, when you're dealing with regular numbers, you divide numbers, you get lower numbers, right? It's the opposite in percentages. So if you want to convert a low percentage from an absolute risk reduction, just divide it by what we call the control event rate, and you wind up with the relative risk reduction or the vaccine efficacy, which is a much higher percentage. Now, going back to the example I just gave you, you divide 1% by 2%. This may not be intuitively obvious at first, but it comes out to 50%. It's much higher. So there you go. And that's what's happening with the Pfizer and the Moderna vaccines. The absolute risk reduction, when you do the numbers, you crunch the numbers. And by the way, I have a calculator, an online calculator that's cited in my vaccine article that people can use. I even have, I put a little tutorial together that I'm trying to get published online to show you how to easily use it, where you can crunch all these numbers very simply. All you need to do is take the number of people in each group and how many people had an event in each group. And you can get all of these numbers. The absolute risk reduction in the Pfizer and the Moderna vaccines were approximately, it was 0.7%, I believe, for the Pfizer and 1.2%, I think, for the Moderna. Whereas the relative risk reduction was 95%, 94%, somewhere around there. Okay. Now you're a pharmaceutical company. Which number are you going to promote to the public, right? You're a public health authority and you want people to get vaccinated. Which number are you going to promote to the public? But is the public getting all the information they need for informed consent? No. And who said that? The FDA, the very people who ran the advisory committee to authorize these vaccines. Okay.
So with all this, you think these are all just honest mistakes over and over and over and over again from all these agencies, or is this starting to look different to you a year plus out?
Let me, I have an opinion, okay?
Yep.
That up to a certain point, yeah, but it's also, honestly, I think a lot of people who are even using these numbers don't realize this problem, right? But not all of them. Some of them do. Specifically, I'm going to use specific name now, Anthony Fauci, I'm sure is aware of this. And how do I know that? He's aware of the difference between absolute and relative risk reduction. There's an online video of him reminiscing about the AZT trials for AIDS back in the 80s. And he's sitting there with Deborah Birx, obviously in the White House when he was on their council there. And he's talking about how the trial was I think it was 8% for the trial to reduce mortality versus 11% for the placebo. So that's a 3% absolute risk reduction right there. So he said, quote, "It hasn't yet reached statistical significance," meaning the treatment. And then he said, "But the data needs to be further analyzed." So I thought, what does he mean further analyzed? Well, what's the way You can take a low percentage of an absolute risk reduction and increase the percentage. You divide it by the control event rate. That's how you calculate the vaccine efficacy. That's how you calculate the relative risk reduction. So he knows exactly what to do. You know what? Somebody should ask him that. Put him under oath. He gets under oath all the time when he's, in front of Congress. Ask him, what did you mean by that? What did you mean by it? The data needs to be further analyzed. Did you mean the relative risk reduction? If that's the number you meant, why didn't you also report the absolute risk reduction? And then why didn't you do that, back then? And also, how many years ago was that? You're still doing it. You're still doing it now, like a snake oil salesman. You're trying to sell this, pass this off as an ineffective treatment for the public. Now, I've used that word snake oil salesman. I'm not trying to slander anybody because I wouldn't dare use that unless I had the evidence to back it up. I mean, let's think about it. Now, put all the information I've been talking about together. Let's link it together. Let's synthesize it together. And what you come up with is a pattern of a snake oil salesman. First of all, they just ignore the science. By the way, I didn't mention that in the New England Journal of Medicine, Fauci had written an editorial where he said the case fatality rate of influenza is 0.1%. That's what I was trying to say before. It's wrong. That's the infection fatality rate. So he doesn't even know the science. He has no regard for the science. That's first step of a snake oil salesman, okay? Second step, you've got a problem, right? And I'm going to offer you a quick fix solution to fix that problem. And plus, I'm going to make you fearful about your problem. I'm going to go out and tell everybody if you're overreacting, you're probably doing the right thing. So I want you to overreact. And here, by the way, is the quick fix. And I underscore the word quick because, as we all know, these vaccines were produced in record time, right? And then he knows they really don't work. If he looks at the absolute risk reduction, he just ignores it. So how is this not like being a snake oil salesman? Again, I will defend, that remark because all the evidence is there. And if he wants to, I'd be happy for him to address what I'm saying, directly and put him under oath while he's doing it.
Well, he's never going to let you do that, and you're just going to be censored before you get within 1,000 miles of him.
I understand. I've tried to email him a couple of times. All I get were automated response, but he wishes me best regards, like the Pope.
So, what's been the reaction to your work? Has it been welcomed or no?
You know what? I have body armor. You know what my body armor is? Peer reviewed. My articles are peer reviewed. So I'm not just out there expressing opinions and, because if that's all you've got, even if I agree with your opinion, if that's all you've got, you are going to be jumped upon. And you should be jumped upon. I mean, we need to have a debate. But to have a proper debate, you have to come prepared with evidence. I am prepared with evidence. I've been working on this for 2 years. I'm sorry. I meant I have 2 articles that I've been working on for 1 year. Sorry, that came out wrong. But that's how long this takes, right? It takes time to get this all out. And I have 2 more articles I'm still waiting to get out there.
Let me make a quick note. Editor, by the way, when you listen to this, please correct his comment and leave out the 2-year part. I just want to make sure that doesn't mess up the recording. Go ahead.
Yeah. Well, it was just a honest mistake. I just corrected. I misspoke. That's all. Okay. The last article I've worked on is under peer review right now. It's about what's called nutritional immunology and how nutritional factors are related to infectious diseases. I mean, nobody even thinks about that. And what I discovered was actually shocking. Let me give you a little bit of a hint. Let me back up for a second and talk about the vaccines once again. The placebo group of the messenger RNA vaccines received injections of saline solution. In other words, sodium chloride. That was it. That's all they got. Now, the vaccine.
Well, I thought some of the placebos were actually a different vaccination. I don't know if that's true or not, but the placebos were not just.
Sometimes that's done. You compare another vaccine with the treatment vaccine. In this case, and I have the New England Journal of Medicine articles. You can look that up actually in one of the articles that I sent to you, stating that they used the saline solution for the placebo. That's it. Okay. Now they use saline also in the vaccine group because you need to use saline to what they call reconstitute the vaccine from the vial that it arrives in. But they only used half the amount. So you have a situation where The one group is getting twice the saline than the other. So why is that important? Here's why. Because there are adverse effects to saline. And you know what they are?
Really? What are they?
Shortness of breath, fever.
No.
Fatigue.
Really? From what is it? The concentration
Rash,
of the saline or the total volume? Like the bolus of it? Or that's crazy.
It's the same adverse effects as the clinical effects of coronavirus, influenza. It's the same thing.
Really?
Now, use that. Yeah, look it up. Use that.
What's the threshold for the bolus amount of the concentration that causes that?
I don't know.
Huh.
You'd have to do
Okay.
a more detailed study. Remember, there are thousands of people in those trials, and I think it was no more than about 160 people in the placebo group, had an event. Now, how much of that event was from the adverse effect of the saline and how much was from actually, getting the coronavirus? We don't know. But the point is there was more of it that could help to account for, the higher rate within the placebo group. By the way, even though there's a 1% absolute risk reduction, some people will say, well, for a million people, 1% is 10,000 people. So we should still do it. My point is, okay, then tell people it's only 1%. And see if they still want the vaccine.
Right.
But anyway, let's get back to this adverse effects of the sodium chloride. There's a big clue right there as to what potentially could be the cause of this whole viral infection, sodium toxicity. I've written an entire manuscript on just this subject based upon nutritional immunology. And I traced it back to all the adverse effects of sodium and how they're all common to the comorbid conditions we find in COVID-19. So for example, you know that COVID-19 is related to hypertension. It's related to thrombosis, stroke, heart disease, arrhythmia, right? Kidney disease, diabetes, on and on. Some of these are more obvious than others, but all of these conditions have one thing in common: sodium toxicity, especially in hypertension and stroke. That's well known.
Let me give you two more things that may pique your curiosity. I don't know if you know already, but I interviewed a fellow that works for one of the national labs, and he told me they had 23 million electronic health records, and they had, I think at the time, 30 or 40,000 samples from people infected with COVID. And he said, they crunched all the data, and it looked like vitamin D was significantly downregulated in people that were sick, which I guess happens with a lot of viruses.
Sure.
So I said to him, oh, well, maybe vitamin D supplementation will help. He said, oh, no, it's got to be a drug that will help, and blah, blah, blah. Right. That's one data point for you. Right. Another one, I had read about the effects of low zinc and the effects or loss of taste and smell, which is also experienced through COVID. So I just wonder if that, if sodium toxicity plus zinc being deficient and vitamin D being deficient all factor into this.
Maybe. I haven't really looked into it. You know what? I already have enough evidence with the sodium chloride. You know what? Your nasal mucosal system, which is part of your immune system, includes your nasal tract, okay? That tract normally clears viruses all the time. By the way, we need to go back. I remember why I was bringing this up. This challenges a lot of the paradigm of the whole virology paradigm. Because I know you have an interest in determining what viruses are. Are they living or not? Where do they come from? What do they do? More importantly, what happens to them, when the body gets rid of them? So my article, and again, I don't want to get into too much detail because it hasn't been peer reviewed yet. It's under the process. Some peer reviewers love this article and some absolutely hate it. The people that hate it are probably like that guy you were just talking about, who would refuse to look at any of the dietetic factors involved, right?
Right.
So.
Well, that's what I was going to ask you is peer review. It sounds great, but if the peer reviewer doesn't like you and they're the strongest one of the group and they say, if you publish this, I'm totally against it. I mean, I've spoken to many scientists that have been blocked. The articles just languished for years. They kept giving them endless corrections or they just won't be approved. So, I mean, how do you choose your peer review group to get through this process?
Well, today we have what we call journal finders, and you enter in your abstract and your keyword search, and also sometimes your reference list, and they will match up the journal that's most suited to the content of your article. That, you see, a lack of proper fit is probably the number one reason articles get turned down. It's oftentimes not because what you're saying isn't true or valid, it's just not a good fit for that particular. Well, in business, that happens all the time. You can be talented and have skills, but if a company can't use them, you're not a good fit, right? It's the same thing. So it's like a bus. There's always another bus. There's always another journal. Just the thing is,
at this point, though, if you're a journal and you're seeking attention and notoriety, I would think you would, and anything about COVID at all, you'd be like, all right, give it to me, because you want to be able to shout through the cacophony of COVID papers.
Yeah,
well, I know everyone has their standards, but still, I mean, I would think there would be a temptation to take on more articles that weren't 100% a fit. I don't know.
Who knows? Everybody has their editorial, strategy. I don't know how they do all of this. So the point is, if it's true, if it's good, if it's useful, your manuscript will eventually be published. So it's just a question of time. That's the problem. It takes so long, though, right? So anyway, getting back to that manuscript, I challenged a lot of the virology concepts. Viruses are pieces of RNA, okay? They're discarded pieces of RNA. In order to understand where viruses come from, you have to know more about messenger RNA. I should have said messenger RNA. That's what they really are, right? Messenger RNA is sent out from the nucleus of the cell with a copy of a genome sequence, which is then delivered by the messenger RNA to the ribosome, which is an organelle in the cell, that the ribosome then can translate the code that's on the messenger RNA. That's why it's called a messenger. It's like a male person, right? And then it builds a protein based upon that, okay? What happens to that messenger RNA after it's used? It's waste.
It could be either reused or thrown away.
It could be reused, recycled. The cell has a recycle and waste disposal system. It's amazing. And it repackages, it decomposes the messenger RNA, fragments it into 12 fragments, and packs it into a bubble called an exosome. When scientists look at those exosomes and they look inside, it's identical to what they call viruses. Now, they're not saying it is a virus, but they're not saying it's not a virus. So that's where it's still, that's where the debate is right now. If you're really talking about the cutting edge literature at the moment in virology, that's it right there. Because if that is the virus, that then goes through a system in your immune system as part of the virome. You've heard of the microbiome? Well, there's also a virome in your system, which is an aggregation of trillions of viruses. Right now, you have just under 400 trillion viruses in you, right? Normal.
Well, if you want to make your head spin, I interviewed a guy that's researching the ARC gene that are in human cells, and the ARC gene actually not only prepares an RNA sequence, but it also fashions a capsid that looks incredibly similar to some known viruses. And that's then sent out by the cell just as exosomes or extracellular vesicles are as communication to other cells.
Right.
So, I mean, literally the body is capable, it appears in some circumstances, without a virus causing it, of producing literally virions itself with RNA packages inside them.
You got it. People say, where did this coronavirus come from? Oh, it escaped from a lab. Maybe. But you know what? You make your own coronaviruses. That's the part that nobody's talking about, right? And that's the part where you're going to get debate. Of course, you're going to get a lot of strenuous debate with virologists about that. But look at the evidence. Follow the evidence. That's all of my research uses the grounded theory method, where I inductively come to conclusions based upon synthesizing the evidence. And the evidence that I'm synthesizing are all the findings from the literature review. So in the literature review,
to take you back to the sodium toxicity,
right?
If that is a contributing factor, why would that? Is it just been noticed as of last March, or is there something that caused a surge in the number of people that had sodium toxicity?
Well, there's a surge every year. It coincides with the seasonal influenza. And you know what that surge is? That we increase our intake of sodium chloride in the wintertime. And I've got all the articles confirming that over and over again.
Why do people tend to do that, by the way, to store?
Because we just generally eat more and we eat heavier foods that tend to be more. It's as simple as that. Also, lower socioeconomic classes tend to have, more infections. They also tend to eat more sodium chloride because sodium chloride is abundant in processed foods, which are cheaper. That also explains why institutions that serve, meals of highly processed foods, like prisons, like some long-term care institutions, also have this problem. So when you look at it, everything is consistent. It's just, this article is quite amazing. I have to admit, I'm kind of impressed with it. But it's one of those articles where, again, you either love this or you absolutely hate it, because it appears to be almost all circumstantial. Oh, you're just cherry picking. Oh, you're putting that together with that and that. But you know what? Cherry picking means you already have an agenda, and now you're picking out what you want to use and rejecting the rest. I'm not doing that. I'm just following the trail, right? And the trail is telling me what's happening. And these are all the things that I've accumulated on the trail. I synthesize it all together. So I didn't get to the other part. In your nasal mucosal system, which is part of your immune system, you have these little fingers, ciliary projectile fingers.
Are they villi? They're not just cilia, they're villi actually, right?
Well, the villi is more in the intestines, but it's similar to that. The villi help to absorb things. In the nasal mucosa, the cilia push things out, okay? What they're pushing out are, among other things, those viruses, those that you're clearing through your waste disposal system. Remember, they were packaged up in exosomes and we don't need them anymore. Thank you. And they come out through through your gastrointestinal system. They come out through your salivary glands and also through your nasal mucosal system. Those are the general exits of this. Sodium chloride paralyzes that action. And that is laboratory confirmed. And that's been known for years.
Okay.
So there, you start putting all this, there's much more to it than that. How are we doing for time? So there's, during the 1918 pandemic, the United States Navy conducted some experiments. And it's funny, nobody has brought this up yet. I'm really surprised. What they did was they did clinical studies. They took sailors and they forced them, or maybe, I don't know if they forced them, maybe it was all voluntary. Let's just say it was voluntary. I got to be careful that I don't misspeak here, right? So they put them in close contact with influenza patients. And we're talking about having the influenza patients cough on them, breathe in their face. They injected the sailors with the sputum from these patients, from the blood, with the blood of these patients. You know what the outcome was? Nothing. There was no effect. There was no transmission of the infection. They did that in Boston, and then they repeated the same experiment in San Francisco.
Well, how did they specifically transfect people? Was it by injection or by
everything? They did
inhalation,
injection, just smearing them with all kinds of vile things, right? You can read about this. It's coming out in my last article, the references there. But you know what? They said, we're stumped. We don't know. We don't know what's going on. We thought this would be, proof that a viral infection transmission. See, that's the distinction. There's a difference between transmitting a virus and transmitting an infection. The infection comes that you develop within, right? You can breathe in somebody's virus, and I've got a lot of evidence from the literature saying that that's not sufficient to overcome what they call the barriers to infection. You can't really infect somebody that way. Now, what are all of our mitigation measures, predicated on? Stopping viral infections through transmission. I mean, it's nonsense. It's not, there's no evidence to support it. None. In fact, the evidence shows just the opposite, that they wouldn't do a trial like that today because it would be considered unethical, right? To expose people to sick people in that manner.
That's absurd. Why is that unethical and all the stuff they're doing completely ethical? It's ridiculous on its face to me.
Well, you could argue that, and I wish you luck, but I'm just saying people would be a little bit more hesitant to do it now.
I guess it's ethical to force the vaccine on people and to lock them in. That's all. That's wonderfully ethical, and to wear masks that peer review studies show are useless. But and social distancing. Have you seen any papers on it? Anything that's peer reviewed on that at all?
No. Well, what I saw was the World Health Organization came out with a review of mitigation measures for influenza pandemics, and they concluded that all of these things, except for the lockdowns. Lockdowns were totally new, but everything else, the masks, the contact tracing, all this other stuff, were weak evidence. There's not enough evidence. Now, the lockdowns, I already explained how that came about, right? And we know what's happened with that. So it's a mess out there.
So if you think this is not planned, it's just a series of errors that seem to be perpetuated, to ask you the question, what is the end game, probably won't make sense, but I'll instead ask you, over the next year or two, what are your thoughts as to what's going to happen? Are people going to magically wake up and come to their senses, or where are we headed?
This is why I'm talking to you. We need to get this information out. We need to open up the conversation again. We have to get rid of this yoke of living under a totalitarian dictatorship, because that's exactly what we've self-imposed on ourselves at the urging of the World Health Organization. So we've got to start getting this information out, free everything up, and let people make up their own minds. I'm not trying to advocate for vaccines or against vaccines or treatments or no treatments, or I'm just trying to get the truth out so people can have more information to make informed decisions.
What's been your personal experience, though, with your communications with various entities or your submission of papers? And have you encountered any pushback or resistance or censorship, or you've been okay?
That's a great question. I'm glad you asked that, because I can report that everything's been fine. And what I attribute that to is that I've done my homework. I'm prepared. That's the body armor I was talking about. I don't make any statements that are just opinions, at least not in my scholarly work. Now, I have my opinions, and I'm certainly entitled to express them, but I make the clear distinction between my scholarly work, which is all based solely upon, other evidence that I've synthesized together. And I don't know where it's going to lead. I didn't know where any of this was going to lead. You follow the trail of the evidence. That's the beauty of this. I wrote an article on this whole method called Breakthrough Knowledge Synthesis in the Age of Google. How to use digitized literature from to form a literature review where you synthesize together all these relationships between all this data. I understand that, you're into that. I was reading one of the prefaces in your book, and you were basically talking about the same thing. I specifically call that knowledge synthesis. You're synthesizing together, information. It's the highest level of education in Bloom's taxonomy of, educational objectives. Synthesis, knowledge synthesis is the highest level you can get to, where you're creating new ideas. This is the idea behind breakthrough knowledge. And I have faith in that. So to answer your question again, I have faith that if we continue on putting together this type of information in this manner, we will come through with those breakthroughs that will break through this, totalitarian, whatever you want to call it, censorship bubble that we're in, break through that and get out the real knowledge to the people, the real truth. That's what keeps me going every day.
No, that's excellent. All right, Ron, what's the best way for people to find your papers and find out more and to hear from you directly? Where can they go?
Well, you can do a Google search, Google Scholar, and put in my name, Ronald B. Brown, and there are all my articles right there. That's the easiest way.
Okay, great, excellent. Ronald, thank you for coming, and I'm glad that you're not just saying things, shooting from the hip, but again, you're really trying to get facts behind everything you say, and it raises the level of the debate, and I appreciate it. All the people that are against all these measures benefit from you because you assemble all this data and this knowledge. So I appreciate that. I just want to let you know.
Well, I appreciate the opportunity to come on and discuss all this information, Richard. Thank you very much.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.